Hi, today's topic will be on projectile motion. We start from a very simple one until very complicated situation. Yeah. So this one is projectile motion. Okay, the projectile motion actually is comprises of two type of motion. One is a horizontal, another one is a vertical motion. Okay, the vertical motion can be considered as a free fall. Okay, under free fall. So first we look at types of projectile motion that is going to study. Okay, so type of trajectory. Okay, type of trajectory. Trajectory means how they move and how we throw how they move. Okay, so we look at the first type. So the first type will be a very typical type where we are on a flat ground and then we launch something. Okay, an object. You launch the object at a velocity u at a launching angle theta. So what happened next to the object is the horizontal component of the u, okay, which is a u cosine theta, will bring the object horizontally to the right hand side in our case here, and then the u sine theta, which is a vertical component, is going to launch the object up. Okay, that is under the free fall condition. So that two motion end up causing the object to have this type of parabolic motion. Okay, it reach a maximum height and then after that it's going to come down again. If there is no air resistance, the object's motion, the trajectory should be symmetrical. Okay, symmetrical means if we throw a center line here, both sides will be the mirror image. Okay, so that one is one type of what we call that projectile motion. Okay, second type. Okay, the second type will be launching from a building, okay, from the top of the building, okay, from the top of the building horizontally, right? So that is a building, and then we launch an object horizontally. Of course, this one with a velocity again u and the angle is 0. But since this object here is actually being launched out horizontally, so it don't have a vertical initial vertical velocity. Okay, so it just started to drop down. So by the time it drop down, the trajectory will be more or less like this. Okay, so that is a second type. And then the third type, okay, third type is more slightly more difficult actually. Let's assume you launch something from the side of a cliff, okay, and then this is the sea water, okay, this is the sea surface. So this is the cliff. So launch an object, okay, at a certain angle, okay, at a certain angle like that. Okay, so referring to this line here, the angle is theta with a velocity u. So what happened to this object is it's going to go up, okay, and then more or less like this, yeah. So it's going to like move up, and then finally reaching a maximum height, and finally go down to the sea surface. All right. So now the difference between the first type and the third type is this. This one, after it reached the ground here, the displacement is 0. But for this third type, after it reached the sea level, the displacement is the negative of the height of this one. Okay, the height of the cliff. If the cliff have a height of h, so the displacement of this object will be negative h. Okay, negative h. So these are the three types which is actually very common in projectile motion. All right. Of course, there are some other type. Okay, some other type in let's say in a further mathematics or in a further physics application. So those type we don't discuss here because those are very complicated. Okay, you need actually more mathematics to deal with it. So now we are going to look at what will be asked. Okay, what you need to know about this type of projectile motion. So we look at all of them. Yeah. So now first we look at the first type. Okay, This one is called the maximum height. Okay, this is called the maximum height. So we call it H max. Okay, so this one also have a maximum height, but the maximum height have two possibility, whether it is from here or from the sea level. Okay, so there are a few possibility whether it's this one H max or H max prime, right? So that's two different. I have to look at what the question is asking. Is it the maximum height from the cliff surface or the maximum height from the sea surface? Okay, so this one we don't have because the maximum height for this object will be exactly the same as the height of the building. All right, so that is the first one, maximum height. So we have H max is the maximum height reached by the projectile. Okay, projectile. Something that you throw is called projectile. Yeah, something you throw is called projectile. Okay, next one is the distance, the horizontal distance travel. Okay, the horizontal distance travel, like in this case, this distance here. Okay, this is called range R. Okay, range, or this one also have a range. Okay, range R. This one also have a range. So this range here have to be very careful. It must be from here. Okay, so starting from here and until it reach the sea surface again. So that one is the R. So our R is the range. Okay, so range is the horizontal distance covered by the projectile motion. Okay, by the projectile motion. Yeah. So that one is a second thing they will ask you in your exam. Okay. Now the next one is, now look at this scenario here. The object, let's say you have a stopwatch. Okay. When the object is being launched, the starting time is t equal to 0. Okay. So you start your stopwatch here until it hit the ground again. Okay, until it hit the ground again. So we will call this one point A and this one point B. The launching point is a landing point or impact point. So the time from A to B, I will call it TAB. Okay, so here also the same. If we call this one A, this one B, so we have a time of TAB. And also here, this is point A, impact point is B, so we have a time of TAB. Now, what is TAB? TAB is when the object is still in the air. Okay, in the air. So the TAB, there are a few names for this TAB, the time for the object flying. So that one is called time in the air, number one, or it is also called time in flight. Okay, time in flight. So it's either time in the air or time in flight. Right? So time in the air, not contacting any object. Okay, so fly here, stop here. So there's a time in the air or time in flight. So these are the three things that they will ask you. Okay, so the difficulty of the question also sometimes depends on the level of study. Okay, the level of study. But for diploma level, normally they will actually ask you these three things. Okay, maximum height, range, and also time in the air. All right, and then sometimes for like STPM, they might have something more difficult than that only. They will maybe ask you, okay, what is the final velocity, or what is the velocity of the object during impact point? Okay, during impact point. That one is a bit more difficult because you have to calculate the component again. After that, you calculate their magnitude and then you find their direction of the velocity when during impact. Okay, so that one is depends on your level of study. Okay, so more or less like that. So I'm not going to give you any new equation because the equation that you already know in kinematic, like v equal to u plus at. Okay, v square equal to u square plus 2as, and then s equal to ut plus half at square, and s equal to half bracket u plus b multiplied by t. All those four equations in the kinematic equations can be used. The only difference is you you change the A into G, and our G is always negative 9.81. Yeah, remember. So things to remember here. Okay, so I write this one in red color. Okay, so things to remember. Right. So things to remember, we have a few here. Okay, we look at number 1. We are using coordinate system. Yeah. Okay, Cartesian coordinate system. So you have a horizontal, you have a vertical. So the one go to your right hand side normally will assume to be positive, and then the other side here will be negative x. And then the one going up will be positive y. The one come down will be negative y. Any vector, especially the vertical part of the component, any component or any component that is pointing upward is positive. The component that point down will be negative. So our G is pointing down. So our G, second one is our G, because it's a vector which is actually accelerating downwards. So we have a negative 9.81 J meter per second. So that is our G value. Okay, but since our calculation we consider just straightforward negative 9.81 without considering a J, because we know of course it is in the J direction. Okay, so that is the this one. All right. So and then the third one is time is always larger or equal to 0. All right. So in our calculation, because projectile motion normally produce a parabolic trajectory. Parabolic trajectory, when we try to solve their root time, okay, there are two answers. One will be maybe negative, another one positive. All right. So that is why we need to specify that t is always larger or equal to 0. If t equal to 0, there's no point calculating already because that is not yet launched. All right. So normally it's a positive answer that we take. Yeah? So these are the things to ponder, and you have to remember all these requirements here. So it's make your job easier. Okay. When you do calculation, it will be much easier. Okay. So here we're going to do look at a few examples. Okay. Before that, the equation that we need to use. Okay. So kinematic equation. Okay, use the kinematic equation that we're going to use to solve all this problem here. Okay, we have the first one, v equal to u plus at, right? And then number 2, we have v squared equal to u squared plus 2as. And then number 3, we have s equal to ut plus half at squared. And the fourth one, which we actually seldom use, is this one. All right. So now this one is normally used when you have different value of a, okay, acceleration, but under free fall, okay, or projectile motion, okay, or projectile motion, our a is replaced by g. Okay, so that means our equation is going to become v equal to u plus gt. Some books would refer this one become negative, but if in that case your g will be positive 9.81. Okay, so in this case we don't want, we just put a, replace a by g, and then our g is negative 9.81. It solves a lot of problem because you don't have to memorize new equation. Number 2, v squared equal to u squared plus 2gs. Okay, and then the third one, s equal to ut plus half gt squared, and the fourth one no changes because it don't have any a value. Okay, so most of the time we don't use the last one. Okay, we don't use this one most of the time. Yeah? So we're going to use this one, this one, this one so often. Okay, especially this one. Okay, when you need to find the time, yeah, this one. Okay, so that is our kinematic equation use. Okay, so next we're going to look at some example. Our example, we have a few category. Okay, we have a few categories, start from very simple to very difficult. So this is our page 1. Okay, now page 2. Okay, our page 2, here, page 2, example. Okay, example 1. So we're going to separate this one into, we can actually do 4 examples on this page here. So this is one, and this one here. Alright, so our example 1. Okay, oh, there's a bug, want to study projectile motion also. Alright, now our example 1, we starting by using horizontal ground. Okay, horizontal ground. So we have an object. Okay, we have an object, launch. Okay, launch at with a velocity u is equal to, let's say, 40 meter per second at an angle of theta equal to 60 degree. Okay, theta equal to 60 degree. So now calculate 3 things here. Okay, calculate 3 things. A, calculate the maximum height reach. Okay, the maximum height reach, number 1. And then B, calculate the time in the air for the object until it actually hit the ground again. And then C, calculate, okay, calculate the impact, calculate the range. Okay, calculate the range. Alright, calculate the range. Okay, so these are the 3 example 1 with 3 sub questions there. Alright, so we look at number 1. Okay, calculate the maximum height reach. So the maximum height reach is only for the vertical component. Okay, related to the vertical component. So we are going to find the vertical component. So our A, the vertical component will be the uy. Our uy is u sine theta. So that one will be 40 sine 60. So our 40 sine 60, 40 sine 60. Okay, we have 34.6. Okay, 34.6 meter per second. So that one is the vertical part. Okay, the vertical component of our this one. Now, when you look at this projectile motion, it's going to reach the maximum height. After that, it's come down again. Now, when you see the whole projectile motion from the front, you actually see the object just simply moving up and down. Okay, moving up and down. For example, if I use a piece of paper to show you, okay, something like this, right? Okay. Okay, so let's say we have this projectile motion. Okay, so when we launch it here, it's going to end up here. This is a A, this is a B. So it's like, from our point of view, object not only moving up and down, but it also move to the right hand side. So this is what we call the two-dimensional problem. Okay, now if I ask you to go to this direction, go to this point here, and then see the whole process, your friend, let's say, launch something up and down in your direction, you actually gonna see something looks like this. Okay, so the object will actually see, the object is here, right? So when I do like this, you can see the whole profile of the movement. But if I actually make it even become perpendicular to the surface of my table, so I'm gonna see that it's like moving, even though my pen is tracing the trajectory, but what you see is only pen is moving up and down. Okay, so we are using that concept here. Only consider the vertical motion now. Okay, we only consider the vertical motion. So what's next? By the time it reached the maximum height, you see, remember the one we traced just now, moving up and down, but before it come down again, it stopped for a while at the top. So the Vy is 0. Okay, the Vy is 0. So next we have your G is equal to negative 9.81 again, meter per second. And now we want to calculate the maximum height, okay, which is S, no? Okay, the S value. So the displacement, yeah. Okay, so now we're going to use what equation? You see, you have this v, you have u, you have g, and then you want s. So we are using vy square is equal to uy square plus 2gs. Okay, so this one will be 0. This one will be 34.6 square plus 2 times negative 9.81 s. Alright, so our s is equal to, alright, so this one we square it and then divide by 2 and then divide by 9.81 again. So we're going to get 61.2 meter. So that one is the maximum height reach. Okay, maximum height reach. Okay, so there's the first one, A. Okay, positive, so that means it's above the launching point or above the ground. All right. Okay, next one, B. So the B, calculate the time in the air. Right, calculate the time in the air. So our time in the air, we are going to need t, find t. So time in the air means what? Is up and down again. So that means the vertical displacement. So we still consider the vertical component of the motion. Okay, vertical component of the motion. So now we have this starting velocity, okay, starting velocity, which is our uy again, 34.6 meter per second, and then we have up and down. You see, up and down to the same level, so the displacement vertically is actually equal to 0. Okay, so another one is the g again is negative 9.81 meter per second per second. So after a few examples, I'm going to not going to write this one anymore, okay, because I assume you know already. And then we need to find the time t. All right. So time t. Look at the formula. Look at the value given s u g t. So I'm going to use the third equation, s equal to ut plus half gt squared. All right. So now this one is 0. This one is 34.6 t plus half negative 9.81 t squared. Okay. So since this one negative, we move to the other side. So it becomes this one divided by 2. We're going to get 4.905 t squared minus 34.6 t equal to 0. So now we got two answers. T equal to 0. Another one is t equal to 34.6 divided by 4.905. Alright, so we're going to get 7.05. 7.05 seconds. There are two answers. So why the first answer not accepted? Because our criteria here, look at this criteria. Okay, this criteria said that the object moving up and down to the same level, so the displacement 0. But there are two times when the object has a 0 displacement. Before it is launched, after it is launched. Okay, so that's why you have another answer is t equal to 0. It makes sense mathematically, but physically we want this answer. The answer is the second one. Okay, this one. But you need to know like this. But the negative one, no need to know. Okay, the 0 is because it's not been launched yet. Okay, and the second time is, so that means not been launched after 7.05 seconds is actually have another time the displacement is equal to 0. Alright. Okay, so that one is a time in the flight. C. There we calculate the range. Well, range R is actually related to what? Horizontal distance is equal to the horizontal component of the launching velocity multiplied by the time in the air. So that's why if this one is wrong, your time in flight is wrong, your range is going to be wrong. Okay, so be very careful when you do the calculation. They are actually all related. Yeah. Okay, so our this one here, ux, anything that is actually perpendicular to the gravitational field is not affected. Okay, so it will be constant. So this one is going to be u cosine theta. Okay, so the u is just now 40 and then cosine 60 degree and then multiply by the time of 7.05 seconds. Yeah, so this one cosine 60 is half, so we have 20 multiply by 7.05, so we have 141 meter. Okay, 141 meter, 141 meter. All right. Okay, so this is a simple example. Well, I consider it's a simple because there is nothing, not much vector is involved here. Okay, look at example 2. So example 2, I'm going to increase the difficulty. Now I'm going to launch object from the cliff. Okay, from a cliff. So here is my cliff. Okay, cliff, and then the sea, water. Okay, sea surface is here. Sea surface. This is our cliff, and the cliff from the sea surface have a height h, and our h is equal to, let's say, 200 meter. Okay, 200 meter higher cliff. So I'm going to launch an object at 60 degree. Okay, at 60 degree from horizontal. So it's going to launch 60 degree more or less like that. Alright, so 60 degree with a u equal to, let's say, 20 meter per second. So this is what happened to the object, okay, in the projectile motion. It's going to move up, okay, reach the maximum height, and then it's going to come down again. Right, so here, like this. Okay, so it's going to hit the water surface somewhere here, and then, okay, so you see, it won't hit the water surface vertically downward 90 degree to the water surface. It's at a certain angle, and that is what I want you to calculate later. Okay, so the question now is same thing. Okay, so calculate. There are 4 things now. Calculate the maximum height, from the sea surface. I mean this one here, right? And then number two is to calculate, okay, the time in flight. Okay, and then C, range, no need, I don't want to find range. So now is the impact velocity. Impact velocity means during the impact with a sea surface, the velocity. So be careful, velocity is a vector component, vector quantity, so you have to give me the magnitude and also the direction. Okay, so these are the questions needed. So now I'm going to calculate. First one, A. So A is to maximum height from the sea. Okay, maximum height. So that means you need to calculate this one first. Okay, so need to calculate this one. Alright, find this h. Okay, find this h. After that, you sum up with this small h, you get the maximum height from the sea. Okay, alright, so we find our h. Okay, the big capital letter h. So we still consider vertical motion, right? Short form. Consider the vertical motion of the projectile motion. So we need uy, which is equal to 20 sine, angle here is 60 degree. Okay, this one is 60 degree. So we have sine 60. So see what you get. So we have 20 sine 60. Okay, answer 17.3 meter per second. Okay, 17.3 meter per second. That is our uy. And then we need to consider what? Because by the time you reach the maximum height, your vy is equal to 0. And then our g, negative 9.81 meter per second, and we need to find the s again. Alright. Okay, so this is more or less the same like this example 1a. Okay, next we're going to use this equation, 2gs. This s actually is y lah. Sy, you can actually put the sy here. Sy. Oh, sorry, here forgotten. H maximum is equal to 61.2 meter. Okay, H maximum. Okay, come to this one. reach maximum height 0. This one is 17.3 square, and then plus 2 negative 9.81 SY. So we want to know what is our SY here. So we have 17.3 square, okay, and then divided by 2 divided by 9.81, we have 15 meter only, okay. So we have 15.3 meter, okay, 15.3 meter. So our maximum height from the sea is equal to our SY plus our small h. So we have 15.3 plus 200. So answer is 215.3 meter. Okay, 215.3 meter. Okay, so that is our maximum height from the sea surface. Okay, maximum height from the sea surface. Next one, B. So B is the time in flight. Okay, time in flight. Now we still consider vertical motion. Realize that most of the time when we deal with projectile motion, we need to consider vertical motion. Okay, consider vertical motion. We have this. Uy just now is 17.3 meter per second. Meter per second. And then we have what? It go up and down. So you see the impact point is here. So impact point is below the launching point, so it has a displacement of what? Negative h, right? So negative 200 meter. Okay, negative 200 meter. Remember, displacement is a vector. And then we already have what? We have one more thing is the g, negative 9.81 meter per second per second. We need to find the time in the air, okay, or time in flight. So again, our equation is Sy is equal to Uyt plus half gt square. Now this one is not that easy because your Sy is not 0. So I have negative 200, and then we have this one 17.3t, and then if I put in straight away, I'm going to get negative 4.905 t square. Rearrange the equation, give you this t square minus 17.3 t minus 200 equal to 0. Okay, this one you cannot factor it, so we need to use the one from the calculator. Equation. Okay, you choose equation here. So equation, and then we have two. Sorry, this one is let's see. I think not here. Okay, I'm actually not very good using this calculator. Mod computation standard. Okay, I think it's this one. Should be this one. Okay, or any more degree? What is this? If let's say choose 2, not this one. Okay, this I'm having problem using this calculator, so I will pause for a while, get my Hi, I'm back. This one, okay, see, equation 5. Okay, so now I'm using the third one. Okay, third one. Okay, so the value is 4.905, enter, and then minus 17.3, enter, and then minus 200. Right, so now all done. Okay, answer first one come out. So the first t value is 8.39 seconds. Okay, the second one, this one I'm talking about, the second one is negative 4.86 seconds. And as we know, okay, since t is larger or equal to 0, so our answer is the time in flight is 8.39 seconds. Okay, 8.39 seconds. So that's what I'm talking about just now. Okay. Alright, so there is a time in flight. And now the impact velocity. Okay, impact velocity. So impact velocity, this one is a bit complicated here. So look at number C. Okay, so first we need to know, if you look at this diagram, yeah, this object actually, by the time it hit the water surface, its velocity is in this direction. See? So this is the final V value. Okay, and then it has two components. Okay, it has two components. One is this one, the vertical component. Another one is a horizontal component. If we split it into two components. So this horizontal component here just now is a Vx. Vx is equal to Ux because the horizontal component Ux is not affected by gravity. But this one, yes. The Vy, yes. Just now Vy here is 0. So now this Vy, because pointing down, should be negative. So need to consider the vertical motion again. Okay. Consider vertical motion one more time, and we need to calculate the Vy. Starting with Uy is equal to 17.3 meter per second, and then displacement is again negative 200 meter, and then the Vy is what we want to know, and then we already have the time here. See, you can use this time. So the okay, you have the time of flight. You can use this one, and then the G is equal to 9.81 meter per second. Okay, so we can calculate using the easy one, which is this one. Vy is equal to Uy plus Gt. Remember, V equal to U plus At, like that equation. So we put in this value, 17.3 plus negative 9.81 multiplied by 8.39. Okay, see what do we get? So 17 point, this one 17.3. So I have to minus this 9.81 multiplied by 8.39. Okay, negative, see? Negative 65.0 meter per second. Okay, and then of course our Vx is equal to Ux, which is 20 cosine 60. Okay, so the answer will be 10 meter per second. Okay, 10 meter per second. Okay, now we draw that diagram. Okay, we draw that diagram. So you see, you're going to have this. Use blue color. So this one is your Ux. Vx. Okay, Vx, and then you have this one, your Vy. And when you combine these two together, you get your final V. There is a direction, see, direction of the final velocity. Another thing you need to calculate, angle also. Alright, angle. So the magnitude is not a problem. The magnitude will be Pythagoras theorem. Okay, Pythagoras theorem. So your V magnitude is equal to square root. Okay, square root what? Square root this one, 10 square plus this one. Negative 65 square. Okay, so we're going to get what? 65 square plus 10 square, and then everything square root. So we have equal to 65.8 meter per second. Okay, 65.8 meter per second, and then we have angle. So angle, we use tangent alpha. Okay, tangent alpha is equal to the Vy over the Vx. So in this case, it will be negative 65 over 10. Okay, negative 65 over 10. So now that is negative 6.5. Arctangent, negative 6.5. So we're going to get a negative angle here. So your angle during impact is negative 81.3 degree. Okay, meaning of negative 81.3. Negative means the angle is actually below, okay, the horizontal. Okay, so this is a C surface. You calculate the angle below that horizontal surface. All right. Okay, so that is our example 2. Okay, this is our example 2. I think these 2 example is good enough to show our projectile motion. Okay. I think that's it. I overestimate the difficulty. Alright, so that's it for the projectile motion. Okay, see you again next time.